Hi, everyone. Thanks for joining me on this session today. My name is Sai. I'm a solutions engineer at Couchbase. I'm not sure if anyone of you heard of Couchbase before. It's a NoSQL database, basically. So today's session, I'm going to kind of take you through. I'm not a machine learning expert by any means, and it's something I won't even claim to know about. It's more about, a fraction of what machine learning can do, but more importantly, what are the challenges when it comes to sharing the data more at the federation side of it, and how Couchbase can fit into this. And that's where we are going today. Right. So anyone in the room, if you've got any questions or anything at the end, you can ask me. We are also in the expo. We have a stand there. If you can come visit us, if you want to learn more about what the product can do. Yeah. So this is the agenda for this talk here. We'll just briefly touch on edge computing, the advantages, the challenges it brings, and then we will try and see how we can address those challenges with our mobile solution, which is Couchbase Mobile. Okay. How many of you in here today are mobile developers? Any mobile application developers or ML, AI ML developers in here today? Okay, okay, few of you. All right, cool. So you know that this is something which is kind of hot at the moment. There's lots of chatbots. There's a lot of work going on at the moment in the AI and machine learning side of it. So that kind of brings to us in terms of the creation of data. There's a lot of data being created these days, mostly at the edge. So everyone's got a smartphone these days. Everyone's got tablets. There's a lot of IoT devices out there, and there's a lot of information that gets generated at that level. So as per some market research, there's a lot of information that gets generated, and it's only going to grow into billions. So there's a lot of focus. There's a lot happening at the edge. And that's where we're kind of seeing the growth in the industry. So by 2025, the prediction by Gartner is that the enterprise generated data will reach about 75%. At the moment, it's 10%. So we're seeing exponential growth in terms of data generated on the edge. So why do we need to process data at the edge? So we have central servers. We've seen the client server architecture. We've seen the cloud. There's a lot of cloud utilization these days. So what is the necessity to process the data at the edge? I mean, of course, if you look at the devices now, they are much more powerful than mainframe computers. If you look at 80s, just an example, if you look at iPhone 12, for example, it's 5,000 times faster than Cray 2, which was a mainframe computer. So it can do teraflops of processing speed compared to those computers in those days. So you have the processing power in your hand as a device. So why not utilize it? Why not do the processing on the edge, and be closer to the customer or be closer to the user and utilize the speed and performance, give that personalized experience, or give that seamless experience to your end user. That's one of the things. So, I mean, that kind of is fine, but processing data at the edge, so it basically reduces. These are all the good things. It's offline. It reduces the latency. It improves the privacy. This is a big deal again. So a lot of applications or a lot of customers, or companies, they produce information which is very secure, or it has to stay secured. So when it comes to processing on the edge, usually you have to transfer the data across for some kind of assimilation, some kind of aggregation, things like that. So that's something there is a bottleneck over there where you can't share that information across. So there are some challenges as well. So in terms of the speed and performance, fine, but there are certain challenges when it comes to security and privacy, or the complexity involved. You're talking about edge devices, which could be in hundreds, in thousands. There could be small IoT devices spread everywhere. So there are certain challenges in terms of managing the data, maintaining the security of the data, and also performing some aggregations or calculations, or mostly on the machine learning side of it, transferring the data across. There are some limitations as well. So there are both pros and cons on edge computing side. So how do you make sure that the network is secured? How do you make sure the data that doesn't need to leave the device, how it stays on the device? How do you encrypt the data? There are various other challenges that you need to think about as well. Yeah. So just on that, now we've seen edge devices. We've kind of covered the edge concept, processing on the edge, and how the edge is kind of the new space where all the companies, all the businesses are kind of investing heavily in. And that's where the machine learning also is a part where you can implement machine learning at the edge. There are lots of use cases for that. So in terms of, I don't know if anyone, I know that I've seen some few hands raised up on the machine learning side. Just to give you a brief introduction to machine learning, what exactly is it? Everything is machine learning these days. You're using ChatGPT, you're talking to a chatbot, you're using an application asking for help or questions. Everything is done through analyzing the information which is already there and predicting what the user is requiring or what they're looking for. So it's basically a branch of artificial intelligence where you can think of it as a process which kind of mathematically, it basically is a mathematical process which allows you to look at some information and either predict some, what the user is expecting or what is needed for that application to, satisfy the requirements. So in this example, you can see it's an image that gets put through a model, and that basically predicts what that image is. So these are the things that machine learning is actually doing. So we know that we have power in our hands. We have smartphones and tablets, and we're going to now look at some ways of utilizing that power to actually see how it can be useful in terms of generating applications or creating applications more on the ML side of it. All right. So where does machine learning fit into the AI landscape? There's vector search. There's a lot of talk about that. There is LLMs. There's discriminative and generative MLs. There's a lot of aspects around AI where machine learning actually fits in. So if you look at the use cases side of it, there is if you look at e-commerce websites, there is comments or there is suggestions or anything like that. They get aggregated, and this is basically one of the use cases where a content is generated based on existing content, right? And there is also use cases where in the IoT side of it, there is use cases where the anomalies are detected, where the manufacturing process or anything like that, where you can actually utilize this ML or the capabilities of ML to detect anomalies. And I like this part, which is where hybrid search, where you can take a photograph of your car and say, I'm looking for a product which matches this color, and it has to be a certain distance from where I live. It has to be in stock. It has to be a certain price range what I'm looking for. These are all the use cases where AI, mostly ML can be used, machine learning can be used, and of course chatbots. So LLMs are being used everywhere. I'm sure everyone's used ChatGPT, and there are lots of models built on top of ChatGPT where we can kind of focus on your predictions or answers to your customers. So there are lots of use cases, and these all can be fit into, or they need to go through a lot of information which is sitting on the edge. And this is where you can combine the information on the edge using machine learning in giving that, or basically expanding the scope giving your predictions on what you're trying to do in terms of that machine learning space. So how do we bring machine learning to the edge? Now we know that there are devices that people are using. They're very powerful. Those devices have sensitive information that doesn't need to be, that shouldn't be shared. And we also have these use cases where, that could satisfy, that information sitting on the device can satisfy most of these use cases. So then the question is, how do we actually bring to the edge? How do we make sure that we are actually processing the information at the edge rather than sending it back to the central location? And this comes down to the concerns, as I said, the privacy concerns, where you don't want your information to be shared across the networks. There is security concerns. There is also the concern where the bandwidth is it will consume a lot of bandwidth in terms of sending everything to the central location for processing, right? So then this is basically the challenge that we have. In terms of ML implementation, there are various ways you can do. As I said, central ML, this is where the information from all the devices or all the sites or locations is sent to a central location. The information is churned, or the model is basically evaluated, and then that information gets transferred back, or the results get transferred back to those edge devices. Or there is another way of doing it where you distribute the learning between the devices on site. So the problem with that is it's only inference. There is no information. The model doesn't send back the variables to the central location. And the other option is federated learning. So what does that mean? Federated learning is all these devices which are being part of this ML process, they all train individually. The model is sent from the central server or the central location to all the edge locations or the edge devices with the parameters. The edge devices use the existing data on the device and apply that model, and then they basically does the churning of that information and send back the results to the central location, and that goes through iterative process. So and then once the refinement is done, then you've got a model that can be used, and that's basically what a federation does, or federative model does. So today we are going to look at how do we achieve this federated learning, and that's basically the focus of our talk today, right? So as I said, federated learning is a method of training ML model in which the model is basically controlled centrally. The parameters are set centrally and get sent across to the devices over the network, whatever is the type of communication. So that basically gets transferred across. The model is applied on this data, and these devices have information pertaining to that device. It's not the same information, right? So everybody's phones are different, everybody's tablets are different. So there is information on that particular device which is not the same. So these models basically are applied on that data. The parameters are set, and then the churning happens. The model will come out with some variance, and then that gets sent back to the central server. And this is basically kind of an iterative process. The bias or the weights are adjusted accordingly. And then once you have that within the parameters of what you're expecting the output to be, that's basically the finished model, and that can be then used to see unseen data. So that model can then be used for various other purposes. And this is basically an iterative process. So how does this work? So you have that could be a central cloud, or could be a edge device, or something like that has the model. That model gets sent across to all these devices, could be IoT device, could be anything in terms of machine learning. And that model gets used once it's distributed across to all these devices. It gets applied, and then the information or the variables are set according to the data that device is holding. and that information, once the model is applied and the variables are set and the variance is derived, it gets sent back to the central server where the aggregation happens. So that's basically, in theory, what a federated learning is, right? And that's this is an iterative, as I said, it's an iterative process. Once the data is collected, the models kind of averaged out, or it kind of knows how. So these are basically on the rules you set, or the parameters you set. The information is kind of analyzed, aggregated, and then it kind of iterates. So one thing what you are seeing here is those lines there. So that's the focus of the next part of what we're going to talk about. So as you can see, there's a lot of the information. So one thing to remember is the data is not sent across to the central location. It's just the model, right? So the model gets sent to the devices. The data currently sitting on the device, the data is not sent. So this is kind of satisfying the privacy concerns. So it's just the model that gets sent across. The model, the variables are applied at the device levels. It gets churned, the variance is derived, and that kind of iterates. So the model is traveling between the central location and the edge devices in the federation style, right? So that kind of satisfies the privacy concerns, but at the same time, there is still a network or connectivity happening. That synchronization side of it is happening. So that's still a challenge. How are you going to do it? So you've got like hundreds of devices everywhere. So what if there is no internet? What if it stops halfway transmitting the data? So there are other things to worry about in this kind of situation, right? So that's something we will talk about later on. So on the averaging or the calculation of averages, aggregation side of it, there are multiple algorithms that generally are being used. So could be an average. Fed average is where the average weightage is considered irrespective of the device, but that kind of doesn't give you the necessary, or it could be biased because you're comparing a tablet to an IoT device, and you're basically sending the same model to both devices and expecting it to perform. They have different computational power. They have different, information sitting on it. So that's not. I mean, that's mostly used, generally used, the Fed average aggregation method. But there are other methods as well where the devices get penalized if there is a variance. There is a lot of gradients shown in the output that they generate. So you can tweak those parameters, or you can tweak those that variables in order to come up to a convergence where you kind of get a model which kind of is usable in the end, once you've churned all the information and trained the model on all the devices. So there are various ways of aggregating the information or the model information in this kind of federated architecture. Okay. So where does this apply? What are the use cases for federation? There are multiple use cases. These are few of them. Imagine healthcare. The devices basically have the information there. You can train the model to help with your healthcare side of use cases. Autonomous vehicles. They can, these are all the kind of use cases where federated learning can be of use, where you've got the devices on the road, in the field, and you can kind of use the data siloed on those devices, on that particular device itself, just basically training the model on the existing data and then refining the model. And that's basically how you can utilize federated architecture or federated way of generating ML. Okay. So now we'll come back to the question it's a general question, right? Okay, we are going to do federation, but this is something that needs to, you need to expect. We are relying on unreliable networks. or it's internet, right? You don't know when the connectivity is there, when the connectivity is not there. So how do you manage federated ML when you are in this kind of situation? So where the link is broken, the sync has stopped, when the information is not actually reached the central location, how are we going to handle this situation? So I'm going to just introduce you to a mobile capability which is part of Couchbase. So I don't know how many of you have heard of Couchbase or if you've used it before. So this is basically a NoSQL database, but it's not just a database, it's a platform. So you can use Couchbase purely as a cache, but there are other things which it also brings. So I'll just give you a very high level overview of it. Part of the platform is also mobile, right? So as I said, this is a platform where there is a caching capability, it's a data store, it's a key value store, but also it's got other capabilities that come within the platform. And if you look at AI purely as AI ML use case, there are a lot of things that you need in terms of building an AI model or AI application. You need scalability, you need high throughput, you need performance, and also you need analytic capabilities, you need other various capabilities that kind of fit into that workload that you're building on the AI. So we've got that as part of our platform, and part of that also is vector search, which is full text and vector search, which basically gives you that ability to build AI capable models. And not only that, on the mobile front, as you can see, mobile is part of the platform. We allow you to take the AI capabilities to the edge, which means you can run predictive queries on the mobile devices itself and implement AI ML on the devices, which is what I was talking about previously on the federated learning side. Just very high level architecture. So those black lines, this is what I want you to focus on. We've got various services, we've got SDK support and things like that. But what's important to notice is that we've got this streaming protocol internally within the architecture of Couchbase, where the information, it's like more like a pub sub, where other services, all the services know about the data mutations happening within Couchbase. So part of that is the replication side or sync side of it, which we will talk about or we'll look at. I don't know, I mean, some people have joined after I started. Any mobile developers in here or anyone building mobile applications or any offline apps? Okay. So part of the stack is mobile. The cool thing about Couchbase is that the database actually sits on the device. So this satisfies the first requirement in terms of federated ML side of it. So the data sits on the device, never leaves the device, and it is basically local to the device. So we've got that capability. So the data is on the device, the database is on the device, so you don't need internet. So your application is up and running all the time. It's 100% available. And then so the next question was, how do you transfer the data from the device into the central location to do this federated learning? So we've got the sync capabilities. We call it sync gateway. So that basically automatically synchronizes the data on the device into the central servers. And on that sync gateway, you can also set up rule-based access controls and various other protective measures where the information is secure. And of course, on the device, there is encryption at rest and certificate-based authentication, various other security side of it. So that's kind of satisfied. And on the server side, as I mentioned, we have the capabilities to churn that information because we have vector search capabilities. So that's kind of the place where the aggregation or the actual convergence happens. That side of it is also taken care of on this side, on our platform. And the entire, as you can see, the entire end-to-end is encrypted or it's secure. So just very quickly on the light, as I said, it's an embedded database. Could be an IoT device, could be Raspberry Pi, could be a mobile phone, could be any kind of device the database is on it. We, of course, support Kotlin, iOS, and various other mobile development frameworks. So you've got that, and you've got SDKs as well. And then the synchronization, peer-to-peer synchronization also is part of it. This is also a cool feature we've got. So your devices on the edge, if nothing, they can talk to each other as well over Bluetooth or any other kind of communication channels. So that kind of capabilities are part of the platform. And on the ML, focusing on the ML side of it, predictive queries and support for ML models is also part of our mobile framework. So you can actually run predictive queries on the edge, on the devices itself. And on the one which we saw in the middle, the gateway, the sync gateway. So there is bidirectional sync. So this is where the model from the device going to the central location and again coming back, that is possible through the sync gateway part of it. So it supports bidirectional sync. And again, there is security and privacy everywhere. As I said, role-based access controls. You can, secure channels. You can create secure channels, sending documents on those channels securely. All that's possible with the sync gateway side of it. And there's a lot of monitoring also available on that. So this gives you a complete picture of how the federated learning is possible through our mobile framework. So you've got the central server having, the main model. The model gets built on the central server that gets synced. If you want, you can have a second layer as well as an edge location, and that basically is the sync gateway side of it. And then the model can be dropped down into the devices where the actual data is sitting. On the devices, the information is churned, the models churned, the variables are sent back into the main, and the aggregation happens over there. So that's what the whole thing fits into our mobile platform for federated learning. So as I said, you don't have to rely on the cloud. If the cloud is down, the edge devices are still there, edge locations are still up and running. So it's still, up and your applications are still up and running, your data is still there available. And even in the worst case scenario, the devices can still talk to each other. So that's the kind of architecture you would need in order to build a federated learning model, especially on the machine learning side, which is basically what we offer as part of our platform. So there are a few slides on implementing the federated learning. As I mentioned before, we have this cloud, the model being sent across from the data center into the edge devices and back and forth. So that is possible through various frameworks are out there. This one, I don't know if you guys can see it clearly. I guess you can. So this is Python code basically. This is an example showing TensorFlow Lite. TensorFlow is one of the ML models that a lot of people use in terms of machine learning. So we are looking at an example or a code sample of a Python code using our SDK, using TensorFlow Lite, which is basically a light version of TensorFlow, which sits on the mobile device. Could be Android, could be iOS. And we are this is an example where it's processing some information, or some images basically. So it's using Keras, and there's MobileNet V2 model, which is being used in here. And it's setting up that framework to be loaded into the device when the application starts. And then we also are training the device, so that there is some labels coming into the training function, where these labels are basically nothing but variables. So those variables are set. There is a loss function setting up the calculating the gradients within this function, the train function. And then we are also, this is optional. You can also overload certain signatures for inferring the information, for saving it, restoring. This save and restore is also useful, where the synchronization if you want to stop the process in the middle and start it again. So that part is also, or you can generate that into your code. So the overall, you can basically build a federated learning model using our API, our SDK, and this is just an example on Android, and then start training the model. I mean, we will send you these slides if you wanted to have a look at the source code later on, or the code, understand the code later on. But the idea of showing you this is whatever I've spoken about so far in terms of training models, different ways of training the model, and especially in the federated world, what are the challenges that you normally face and how we can help in terms of overcoming those challenges, and then how we can the tooling we provide and the core the SDKs that we provide, how they can be used in terms of building that training the model on your devices. Okay, so that's basically the the gist of this session. I know I've got some time left over, but before I open up for questions, there is also, I just wanted to, I've been told to let you guys know that, of course, as I said, we have a stand here, and we are doing a raffle draw. But more importantly, we've got some beers and cupcakes and soft drinks out there for you guys. Once we finish the session, you can join us and yeah, just have some fun basically. So I've got about 19 minutes left. I know I've gone a bit far. Any questions so far? Is there anything you would like to ask on what I've just gone through? Yeah, sorry.
Yeah, can I please ask from your point of view? Thank you. So can I please ask, from your point of view, what is the drawbacks of the federated learning compare with just having the ready trained model and deployed into the local device?
Yeah, I think the main drawback of federated model is data is not the same. So the model that you're going to send across to these devices, so it needs because the data is different and the information that you're going to apply on the model is different. And also as I said, the device performance itself it's not comparable to it could be a faster device, slower device. So what you get back is probably biased. So there's more iterative. That's where the aggregations, which I spoke about. So that's where you apply the relevant aggregation. So average aggregation probably is not something you should be. I mean, you can still use it, but it will probably not be a good way of getting the predictions. So there is other ways of aggregating that information. More, as I said, you penalize the devices which are underperforming, so that they kind of set or adjust their outputs in order to get that final convergence.
All right, thank you.
Any other questions? Right, so I shall give you back 15 minutes of your time. Thank you so much for joining me, and yeah, I'll see you later. Thank you.